I want to start with a scenario. It's honestly terrifying because it's so, mundane.
Mm.
You get a video message. It looks like your brother, maybe your boss, and the voice is perfect, the mannerisms, everything is spot on.
And they say something like, I'm in trouble. I need you to wire money right now.
Exactly. And your stomach just drops. Your first instinct is to help.
Mm.
But the real issue isn't that you're gullible.
No, not at all. The problem is that the person you're looking at, well, they never actually recorded that video.
And that's what the research is calling the deepfake trap. Right.
That is. And what's so interesting is that this isn't just a tech problem. It's a biological exploit. We are all running on an evolutionary operating system,
An old one.
a very old one, where for millions of years the rule was simple. Seeing is believing. If light from an object hit your retina, it was real.
But that patch, that evolutionary rule, is completely broken now.
Yeah.
The sources we're looking at today argue we have to sort of rewrite our own internal code.
We do. You can't rely on a feeling of trust anymore. Our senses can be synthesized.
So that feeling is now a vulnerability.
It is. We have to shift from trust as an emotion to, let's call it trust as a procedure. We're moving from, I believe this because I see it, to, I accept this because I've checked the process.
Which really gets to the mission of this deep dive. We're not just talking about spotting fakes. We're analyzing the systems we need to build to live with machines that are, well, they're professional liars.
The term the literature uses is plausibility engines. And it's such a precise and damning term.
It really is. It gets the mechanism perfectly.
A generative model isn't a witness. It's not a database of facts. It's just an engine that's been optimized for coherence. Its only goal is to predict the next most plausible word.
So it's not trying to be correct, it's just trying to be convincing. It has no way to distinguish between, I know this from a document, and I'm guessing based on a pattern.
And that is the core error. A model can hallucinate a fact with absolute confidence simply because that fact fits the linguistic pattern it was trained on.
The big challenge for the science, then, is forcing the system to say, I don't know, instead of just making something up.
Exactly, to flag its own uncertainty instead of hallucinating confidence.
The sources use an aviation analogy here that I found incredibly helpful. Everyone wants, like, a single safety button for AI.
But in aviation, safety isn't a feature. It's a whole infrastructure. You don't make a plane safe by just telling the engine not to crash. You have layers.
3 distinct layers, right?
Right. First, you have the model, the engine itself. You train it from the ground up to be cautious.
Okay, so step 1 is a better engine.
Then you have the system around it. These are your brakes, your seatbelts, the automated alarms, engineering constraints that catch failures before they reach the user.
And the final layer?
The human,
Ugh.
the pilot, even the best autopilot needs a disciplined operator who follows procedures and signs off on things.
And that human element, that's where this idea of verification really comes in. The material we looked at outlines 3 key practices.
Sourcing is the first one. It's the most obvious. The system has to cite its work.
But that's not enough for high-stakes fields like medicine or finance.
No. For that, you need external validation. The AI has to check its output against a separate, trusted, independent database.
And then there's role separation. I like this one.
It's the newsroom model. You have one module that generates the content, the writer, and then a totally separate module acts as the fact checker trying to tear it apart.
But what about that video of my brother? The content itself looks perfect. How do you verify that?
That's where the idea of a content passport comes in. You have to stop looking at the pixels and start looking at the metadata.
The digital luggage tags.
Precisely. Proof of authenticity isn't in the content anymore. It's in the chain of custody. Where did this file come from? Who edited it? How did it get to me?
So if a video claims to be breaking news, but it doesn't have a cryptographic history showing it was recorded 5 minutes ago on a real device.
You have to treat it as synthetic. The new rule is, don't look at the video, look at how it arrived.
But, systems fail. When an AI gives bad advice and crashes a market, the chain of blame gets really complicated.
It's like an NTSB investigation after a crash. You have to look at the whole system, the developer, the company that deployed it, the specialist using it.
This is where the risk scale becomes so important. The guiding principle from the research is pretty stark.
Assistant, yes. Unsupervised autopilot, no.
Especially when the cost of an error is high. You're talking about healthcare, critical infrastructure, the courtroom.
In those cases, human oversight has to be absolute. We can't delegate autonomy where the consequences are irreversible.
So if we pull all of this together, the big takeaway seems to be we have to retire, I believe, and replace it with I checked.
Exactly. Don't trust charisma or confidence, not from a human and especially not from a machine.
Hmm.
Trust only what can be verified.
We're building a world where these smart systems are literally becoming our environment.
But we have to remain the architects of their constraints.
And if these systems are the new environment, that leads to a much, much bigger question.
Who owns the environment?
Yeah. Who controls the infrastructure, the compute, the data?
That's the real power question.
Mm-hmm.
And maybe something for us to dig into next time.
Something to mull over. For now, remember, trust is a procedure. Thanks for listening.